Hi, this is Stephen Rara from Raton Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language. This is the continuation of Irvine Chapter 3 demo going along with this. I guess this is part 2. Well, actually, I don't know how I'm going to number them, but I'm going to start off looking at instruction format. So something that was mentioned in the overview has to do with the basic format that a number of the instructions have. The first part, optional, being a label. Well, none of these commands here, lines 22 to 27, have a code label in front of them. It's something we'll get into later, but for this part right now, there is nothing in front of it. This part here would be the mnemonic. So in this case here, MOV, that's the thing that will, and by the way, move doesn't mean it's being removed from where it came from. So in other words, if you move from memory to a register, it's still in memory. And if you move from a register to memory, it's still in the register. It's more like a copy in a sense, copying from the source to the destination. But the MOV is a mnemonic, and so is call. So down here when we're doing the call to dump regs, call is a command for calling a procedure. And so then the operand for that would be the name of the procedure. And here I'm referring to the author's routine, which is called dump regs. Okay, but back on the move, there's all of the moves I did here, they all have two operands. And so the operands, the registers, so EAX, EBX, ECX, EDX, those are 32-bit registers. DH and DL, those are 8-bit registers. So the first operand in all of them is that, comma. Now the second operand, this is what we refer to as an immediate. This is probably a good place for a comment. And so the comment is going to be mnemonic. I'm spelling. I'll have to come back and change the spelling. I don't know if I'm spelling this right. Mnemonic operand, comma, operand. And in this particular case, IMM for immediate, that's a constant. Okay. Since the format for the move, since the format, actually, no, I'm sorry. Let me move this. Well, this is exactly what I would do in class. I would just screw it up. So you guys are getting the class experience. Okay. But in this case here, let me just add in. So move destination, comma, source. And what I'll add here as a comment, destination can be register or memory. And I'll say here source can be register or memory or immediate. And the key thing is that the destination for the move statement, we can't move something into 33, but we can move 33 into something. So the right-hand side of these move statements, these are immediates, that's allowed. We can never have an immediate on the left-hand side. Now, if we're in the classroom, I would refer to the back of the book. And I'll just say, loosely the back of the book, that there's an appendix that actually has all of the commands. And what it will do is for the commands, like if you find the page that has the MOV command, it'll have there a table showing you what's allowed. And it actually will give the combinations of what's allowed. What's not allowed is memory to memory. And the thing that is preferred, or I shouldn't say preferred, with the MOV, the bits have to match. And what I mean by that is DH and DL are 8 bits. So whatever we move into it, they have to fit within 8 bits. So we have to use our like, the operands have to be bitwise, the number of bits compatible. Okay. I went off on a huge tangent because I didn't finish the last one. The last part is, in the instruction format, the last thing is a comment. Now, for those that had me for data structures, the comments that I kept harping on were the Java comments for each method, showing what are the inputs, what are the outputs, what's the at_param and the at_return that a method has, and a description of it. I wasn't as big on comments on the code itself. Well, here in assembly, what you're going to find is for a program that you look at 1 week later, you're not going to know what the hell you did. And I would sometimes make in my other programming classes, I would make the comment that comments are for future you. And usually it's the kind of thing, if you're working on an annual report, it's for you a year from now. Well, assembler, the comments that are put in are for future you, and it could be a day later, a week later, it could be an hour later. And so the comments, it would be more of a description of what's going on, especially because since a register, like when we refer to EAX and EBX, the registers by themselves are not signed or unsigned. They just hold a collection of bits. It's what we move in there. We have to keep track of, are we putting a signed number or an unsigned number in there? And so the comments would have to say what we think is going into that register up until the point we no longer use that register anymore. So the comments become crucial so we can say what our intent is. Speaking of comments, there's a way to do block comments. And so if I do, and the case doesn't matter, but I'm going to scream it just so it stands out. And I'm going to do comment, exclamation point, and I'll come down here, exclamation point. And this is a multi-line comment. This is the like /*/ in Java. And so by doing this, the only thing now, since I just commented out this whole block, and we just add a comment to the comment, that seems funny, block comment. It's flexible for what symbol you can use, and somewhere in the book they list the different symbols that can be used. Now, if you notice, none of the stuff I loaded because the code has been commented out. I have a tendency to use exclamation point because it's not that often I scream in my comments. Yeah, sometimes I do, but not that often I scream in my comments. And so I look at, since exclamation point is not something I normally would put in the code, I can use that for the beginning and the end. So the key word is comment, and then everything between, whatever symbol you use, between the beginning and the end, between those symbols, all those lines are commented out. So by me just doing what I did a block comment out of everything that we, all those lines of code. Okay, I'm going to do a pause for a second. Okay, I just wanted to regroup and figure out what else I wanted to stick into this video. And I think what I want to do is talk about what goes on behind the scenes when we do a build. So I was very quickly doing a Control-Shift-B in order to build, and then looking down here to make sure that actually was compiling. And then I did a Control-F5, which is the same as debug, start without debugging. What I do want to point, and let's go into, I'm in the Irvine folder in the demo chapter 3, main ASM. Now, what I'm going to do is, just so we can see what's in here, I'm going to open this in Notepad++, and then this is everything that I just did up until this point. So I just wanted to show, using the Notepad++, what is in that main ASM file. When we do a compile, so when this main ASM is compiled, one of the things that it does is it writes out this LST file. And so let me just go and take a peek at the LST file. This is kind of like a log of what is going on in terms of the comments. What's behind the scenes is the underlying hex of what is actually being done. And not only that, there's some other things that are going on, and that is because the author actually has some additional things, such as like exit. So on exit, when we type exit, that actually gets replaced with pushing a 0 onto the stack, which we haven't talked about the stack yet, and then calling a routine by having the 0 on top, the 0 returning a 0, which when we run it, I'm sorry, let's come back here again, that exit code 0, that's because that got pushed on the stack. Well, we don't see that in the code. We just see exit. But what happens is that actually is something that the author has written that on compilation is intercepted, and then the code that goes in its place is put in there. And the other thing that's within this file would be an explanation of sort of how the memory is used. The reason why this is so large is because we're using the Irvine library that's being included. Oops. Something I omitted when showing the template. Let's go back up here. I didn't talk about this. That brings in the Irvine library. Think of it as import. So you know how we did scanner in Java? We had to do import java util .scanner. And so then we were able to reference the scanner. And if we use JOption pane, we had to import blah, 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 JOption pane. Well, doing the include, we're bringing in the stuff that the author has. Well, we're also bringing in all his overheads. So because of the routines that the author is putting in, it actually will make the executable file a little bit larger. I mean, one thing, if you notice, this main ASM is 2K, but if we look at the underlying executable that was created, it's 22K. Okay, so the other thing I do want to point out, since I'm down in this folder, this main OBJ, so when we do a build in Visual Studio, so when we do a build, one of the things that it does is it writes out this OBJ file. Inside that OBJ file is the machine language, the ones and zeros. So there's a direct correlation between, so like MOV becomes a series of ones and zeros. That's regarding the instruction set. And what the OBJ has are all the ones and zeros. So it's all machine language. It in and of itself is not runnable. What happens behind the scenes, and this is the nice thing about being in Visual Studio, is we don't have to do an extra step for it, but it does a linker. And what the linker will do is it will take, and let's go back up to the Irvine folder. So the Irvine 32 live, the kernel 32 live, and the user 32 live, for what it needs to reference out of it, it pulls out of there what is needed to go into our executable. So the linking occurs behind the scenes. So when we do a build, the main OBJ is the compiled version of our code, and then the project exe is the result of linking it together. So there is a slide in Irvine Chapter 3 that actually mentions the linker. That is something that that is there as well. Oh, if I'm at 14 minutes, let me end this piece.